right, let's get started, guys. Welcome, everybody. In case you haven't guessed, I'm not Danny. It's okay. Excuse me? All right, the exit's that way. No, I'm kidding. So welcome to Dallas Software Developers Meetup. Thank you, everyone, for joining. You could literally be anywhere in the world right now, but you decided to join us tonight, so thank you very much. That means a lot to us. If this is your first time being with the Dallas Software Developers, welcome. We are a technology agnostic group who don't focus on one single language, but focus on several topics that can help the community grow. So that's what we here are tonight. What else? My mind just went blank. Sponsors. I got my notes here, so let me just go ahead and refer to my notes right quick. So we are volunteers ran through, me being one of them, the co-organizers here, along with Eric Anderson, who's gonna be manning the machine tonight. We also have another young representative, Dennis, Dennis Square. And then we have Clint Myers, raise your hand. There you are, there you go. And last but not least, Mr. Danny Thompson, who's not here tonight, unfortunately. Let's give it up for him. All right, so this is our night of software architecture. This is our take on a mini tech conference, if you will. We do many of these events twice a month. We also do things like mock interviews, which is what we did last time. And we gave people an opportunity to come in and have their resumes reviewed, as well as give awesome feedback to the individuals. The next meetup will be on May 20th. Again, May 20th will be a night of AI. So if you are interested in that, please visit Meetup and sign up for that. If anyone is interested in ever being a speaker for this Meetup group, you can actually go to our website called dallassoftwaredevelopers.org, dallassoftwaredevelopers.org. On there, you can find a registration form under the community, and you can sign up to see if you want to volunteer to do a topic. And we also do cohorts. You can actually register to be notified on there as well. So, a couple more housekeeping items. First, I want to start thanking our sponsors, of course, for Yum Brands. Let's get up for Yum Brands. Love this space here, so it's very awesome that we can be here. Another sponsor is Struct. The guys are over here. They are sponsoring the pizza tonight, so big applause to them.
Hi, friends. I like that, but I want more energy. So let's pump it up. It's Night of Architecture. This was my idea to Danny, and I'm so excited to be here. I want more energy because I'm going to talk about event-driven architecture. Give it up. As you can see, I've been putting out a lot of production fires since last 10 days, so I couldn't prepare any PowerPoint presentation. So you'll have to use up your imagination today and follow along. Yeah? Works? Yeah. To pump things up, I want to divide, like it's already divided, I like it. This side, I want you to clap when I point at you. And this side, I want you to say yay when they clap. Yeah. They're producers, you're consumers. All right. Wait, louder. That's cool. We don't really have a bus in between, so we kind of skipped on it. So those who have already started working or work on event-driven architecture, they know what I meant. How many junior devs are in the team here? Awesome. Awesome. For the benefit of those, the new junior devs, Event-driven architecture is something like what we just saw. We had an event here, someone clapped, right? And we had a response to it. We had consumers who consumed that event and responded to it. Now, what is missing here is a buzz in between that I spoke and mentioned about earlier. Is a buzz is a topic or a queue where all these events that raised an alarm or an event got pipelined, and the subscribers or the listeners or consumers have done something with that messaging queue. They subscribed to it and they started consuming information. Enough of that. That's a subscription producer consumer problem that's very classic in computer science, right? Let's talk about what I specialize in and how that applies in my technology problem solving. I work for ad media. So this is my introduction. I'm Sireesha. I work for a company called Ad Media. We used to be headquartered in Los Angeles, but now in Las Vegas, but we are remote. If there is wood, I want to knock on it. I want to be remote. And thanks. We work in advertising, digital advertising. What's digital advertising? If you go to a website, when you open a website like CNN.com, whatever, you see there are ad spots on the side, square, rectangle, banner, right? Vertical, horizontal. When a website loads, they connect to something called as an ad server, right? So ad media has its own ad server, for instance. And we have this inventory of all these ads advertisers that we work with, like Macy's, Kohl's, State Farm, which, by the way, if you've ever clicked on the ad, thank you so much for giving me your money. So ad server, what it does is it bids. We do bidding to have our ad inventory win a slot and get impressed on the website. So when you load a website and you see the ads loading after a few, let's say, seconds or sometimes milliseconds, that's what is happening when a website loads. And there is an international standard for ad servers to come back in 200 milliseconds. We need to bid for an ad, and the one that bids the highest wins the ad impression, and they get impressed on the website. Yes? Followed? No? Thank you. Now, how does event-driven technology apply to us is we utilize it in many ways. Of course, we have all this ad inventory that I spoke about. And ads are just that. They all have something called as creatives and ad copies. That is advertisement, right? That you see digitally. This is not TV. This is not video ads. I'm talking about banner ads. So they have like a title, a description, a link to click on, blah, blah, blah. All those, the entity properties. Now we have an ability and a, let's say, opportunity to see which ad is performing well with respect to event-driven technology. Meaning if we have shown an ad version A, say that State Farm guy, Jake, right? You all know the ad, right? So maybe the ad with Jake standing and, taking up the whole page, right? With his red jacket and all that. And people, let's say they cross it, then they don't like the ad, right? So we kind of store that response in our architecture and make an educated decision for the next time when someone visits and we want to use that creative to show the ad placement. So maybe users who look at the ad may not want to click or may want to click, and we make those kind of analytical decisions. So that's one way we use event-driven technology. The other way we use is, if you've heard of these terms called cost per click, cost per impression, these are all advertising technology. So cost per click is when someone looks at an ad and clicks on it, and someone makes a commission or a revenue out of it, that's cost per click model. Cost per impression is like YouTube or banner ads, where people, like for every 1,000 impressions, you make money. It's called CPM model. So that's another opportunity for event-driven is in that area, where we are able to figure out which revenue model is fitting well with an advertiser. Someone who is looking at a Macy's ad may behave or generate revenue differently compared to someone looking at or clicking on a State Farm ad. So that's one use case. Then we have something called as, let's talk about the reporting, right? We have this huge data that comes from users clicking. If you've ever visited a Nike website a week ago, but you haven't purchased anything, magically, after a few days, you continue seeing Nike ad, right? When you visit other websites, it's called retargeting. So we kind of know your behavior. We try to make an educated guess about who is this user, what is their age group, what is their demographic, location, and interest. And we kind of try to, let's say, partly advertising technology fault is to make your experience in browsing really miserable, to keep bombarding with the ads. So this is how it happens. They know about you. I think at this point we all know that all these companies like Google, Facebook, Meta, right? They all know about you because of cookies. Even if you take the cookies away, they'll somehow figure out to find out about you. So, and they know what exactly they need to target, and that's called retargeting. That is a word in my world. And that's another opportunity for event-driven technology to milk money, let's say. Right. So I want to wrap it up because I had no time to prepare for this presentation, and I was really winging it, to be honest. But I promise to come back on stage and speak again with a lot of graphics, maybe next time. So they said there is no question and answer, so thank you.
Thank you. Thank you. All right. Our next speaker will be Saurabh. Please come up here. He is the Associate Director of Launch. Round of applause for him, please.
All right. So, okay. So I'm here to talk about mobile architecture. Well, more about mobile apps, the enterprise architecture which is friendly to mobile apps, right? I think I'm stepping back again. Let me hold this. I'm going to move a lot. Is this better? This is better, right? Okay, thank you. All right. So good evening, everyone. Thank you. First of all, I want to really thank you, right? This is an opportunity everyone has, and just reaching out to everyone else who thinks, why am I here versus not you? You could be here too. Just go and register yourself, right? This is an opportunity. Be here on the stage, showcase your skills, and doing this process actually helps you learn yourself and be that better person of yourself, right? Okay, again, thank you, organizer of Dallas Software Group and everyone here for giving me this opportunity. Also, special thanks to my employer, Launched by Antidata, to let me use this slide template. And again, just a disclaimer though, the views expressed are here totally mine and not of my employer. And so okay, let me introduce myself now. So my name is Saurabh Gupta. I am like technology enthusiast, of course, because that's why I'm here, right, I guess. And I'm also a space enthusiast. I grew up watching Star Trek, and I guess I'm going to retire building software. No chance for me to get to NASA, right? So I've been building mobile apps for so many years now, and it's been a common thread for me to when I am as a mobile app engineer or a lead engineer, when I go ahead and actually talk to enterprise architects. And I see, I don't see there's a frustration, but there is clear gap in how enterprise architects really want to play versus how a mobile app consumer wants to consume those information from enterprises, right? So there's clear frustration. So what I tried to do was, okay, how about I put myself in the enterprise architect's shoes and see how this plays out, right? So I'm going to do a role play, or I'm going to ask everyone to do a role play, where I'm going to ask you to be an enterprise architect given a certain scenario. All right, so let's all of us try navigating enterprise realities in this mobile first world. Because yes, we use our laptops, yes, we use our tablets, but what do we use really? Our mobile phones. That's what we want to consume our apps on. Moving on. All right, consider this, right? You are a seasoned enterprise software architect. You've been in that company for like 15 years. You know the enterprise system that is built upon in and out, right? and you find yourself in a meeting with Donna and Grayson. You have worked with Donna multiple times, did multiple successful implementations of enterprise systems. But who is Grayson? Oh, is this the new director from digital transformation team? And soon, while you are like in the meeting, very quickly you realize, they want to launch a mobile app before Thanksgiving, and you only have 8 months to do that. And all you have is a quasi e-commerce app for yourself, right? So what kind of setting am I talking about here, right? So move forward. So the app, imagine we are the organization or a company who sells like seeds, fertilizer, and pesticide wholesale. And this is all made up, guys. I have never worked with the farmers before, but but imagine, right? So imagine you have 4,000 farmers placing bulk orders, seed, fertilizer, and pesticides. And lately, competition has been making inroads in your loyal customers. Why? Because your web platform is not reachable. They're reachable in the rural areas, spotty network, and of course, and just not responsive enough. And you can never ever almost replace a website with a mobile app if you want customer engagement, right? Customer engagement is why everyone is a mobile phone. Even a restaurant next door has a mobile app nowadays, right? So you are faced with some critical decisions in the face of this tight timeline. Okay, what are those critical architectural dilemmas? Now, imagine this is not a guy who actually has built a mobile app before. He's an enterprise architect who has done enterprise architect stuff, right? He has built systems. He's integrated with inventory management, supply chain management, HR system, financial, accounting, all the data, all the sensitive data, all protected on premise. Maybe he has not even gone cloud so much. Maybe for the e-commerce app, they did something on cloud, but that's it. That's talking to a tunnel and going to the on-premise systems. So what are we doing here, right? So what are the dilemmas he's going to face? So as an enterprise architect, and I've realized that, I mean, I can imagine doing some of the cloud native stuff as a mobile engineer, doing and reading aloud. I can imagine as an enterprise architect, you have 3 balls in your hand, which you try to juggle. One is efficiency, other is speed, and third is security, right? So when you say efficiency, I'm going to start thinking, okay, maybe I can reuse my REST API. I have my e-commerce app going on already. It can give me the inventory. It can let me place an order, and it can also let me sign in. Why can I use those RESTful APIs all over again just for my mobile phones, right? Maybe not. Why not? Mobile phones are limited resource devices, right? Your battery life is limited, your CPU is limited, your screen space is limited, right? And how are you going to even fit in or think about fitting in all that information with large JSON objects into that app? So maybe not, right? So that's one question he has in head. Other is speed. Well, I have this inventory management system, which already takes 2 or 3 seconds to get data back. Now we have 100 requests coming to that inventory management system. Do you think it can handle that kind of load and respond on time to that kind of, and it's been all behind firewall. So it's the thing about this, right? I mean, think of when mobile phones came in. They were these guys that was where you do innovation. They were exemplified user experience more than data. But now we're trying to do a different thing. We're talking to these systems which were not supposed to work on a mobile phone. Security is the third ball that you're trying to juggle. Is OAuth enough on a mobile device? Mobile devices are not your tab, or not your desktop or your machines, which you maybe sometimes use on Starbucks. Mobile phones people use outside all the time, right? So, I mean, in those untrusted Wi-Fi networks, how are you going to secure your mobile phone app? So juggling them is tiresome, but not impossible, is what my talk is. So let's dive further. Oh, I forgot to do this. All right, so yeah, we went through the 3 balls, which is efficiency, speed, and security. And we're going to come back to these 3 balls again when we do the final decision at the end of the slides. But let's find out what is an enterprise system. Why do we think it is such a difficult job? Why do I think, and why do I have faced that kind of trouble already, right, in many places? So enterprise system are these structured behemoths, right? Handling massive data, supporting countless users, and is integrating through these many systems just to make sure that everything is running efficiently. On the other hand, mobile apps are like traditionally free birds. I mean, how many mobile apps engineers here? It's just me who's, I mean, what was your first mobile app that you developed? Did you ever talk to like large data? Or you developed that mobile app because it's fun of it, right? Because you wanted that experience or you wanted to try that idea out. You could have just set up the Firebase or Google, Firebase backend and get away with it, right? But not. We cannot do that here when we are building for enterprise. So one of the best analogy I found, and I thought of it, I guess, is think of it like this. I read it online again. So enterprise architecture applied to mobile is like a restaurant using industrial kitchen equipment to serve food in a food truck. The equipment draws too much power, right? Enterprise systems do that. Takes up too much space, of course. That's not. Requires specialized training. You working with enterprise architecture is not an easy job. That's what I'm saying. I'm not an enterprise architect. I'm trying to put myself in the shoes of one, but I am not. And then it cannot handle the bumps on the road. The thing is mobile. So food trucks need compact, efficient, and resilient equipment, just as mobile apps need lightweight, battery efficient, and network resilient architecture. Moving on. All right, so before we come to, as I said, I have those decision dilemmas, architect dilemmas upstated already. Now I'm come to that point where I'm saying, okay, what are the right decisions based on that case study I put together? But before that, we need to understand what are blind spots in mobile architecture or building enterprise architecture for mobile. So those are chatty REST calls, latency and data integrity. API has to be backward compatible, and no one remembers their password on mobile phones, right? All right, let's go one by one. Chatty REST calls. RESTful, I mean, it's the best thing. REST is the best thing for API development, no doubt about it. But by very definition, a RESTful is chatty. Why is that? Because every resource has own set of URLs to get, post, and delete. I guess everyone agrees, right? So, and I'm sure everyone has had that question or had decision thought between your team where, oh, I'm going to get this list of products. Should I do a REST call to get that data? And what should my structure? Because RESTful, again, is about getting the resource only. So anyways, if these REST principles are followed to T, the chances are every time user launches an app, sees a loading screen and until app is ready to show all the data. So you have products, you have orders, you have user data, you have inventory, you have promotions, everything is coming through one calls and you're waiting for all these calls to complete to start seeing something in the app. In a spotty internet connection or slow device, that's a failed, defeated user experience because any one network call fails, you basically are not able to show the app properly, right? So what are the solutions? Now, so the solutions are actually easy to understand because think about it. I am not an enterprise architect again. I know guys who are enterprise architect. Once they know this blind spot, they would think of these things. They would think, oh, I could bash my request. I could minimize the payload. Yes. But then again, as I said, we have to come to the blind spots and problems first to really come to the solutions. Okay. Second one, latency and data integrity. Being user of a mobile phone, we all want that my data should load instantaneously. I open my phone, I unlock it, I'm there, I can see it, I close it, I'm done with my job. That's how fast you want it to be, right? And it's not. I mean, even a simple Simply Safe app, if I have to make it away mode, it just takes forever to load. I mean, that's a bad app for me. Anyway, so mobile users expect data fast. Battery life is directly proportional to CPU usage. Large data set to process, more CPU needed, battery drains. And it's a problem. Everyone in this room has a mobile phone which is running out of battery at this moment, right? Okay. So caching, data caching is also important, but you cannot compromise the integrity of data. Yes, you would like the data to cache so that users can see inventory right away. Because remember the inventory management system, which was running very slow? Yeah, I would do that. But then the inventory is definitely going to reduce. So you have to make sure that the caching, the data that is getting cached is not getting stale. It is getting refreshed very so often. To solve this problem, there are key strategies to implement day one itself. You have to cache data response on edge, right? You have to bring edge caching on your cloud, wherever you're going to get the data from. You have to support lazy loading or pagination, whatever you call it. But I mean, someone who has built a mobile app would know that you would have faced this is when you have building mobile app and you are at the very end of the development life cycle and at the end of stage and almost there is staging, and then you go to production, all of a sudden the map is going slow because all the time the QA testers were testing with data which was a response which was only recurring 100 records. On production, the same set of records is 1 million, right? So you want to make sure you cannot have ever a very good parity between QA data and production. So that's why you want to make sure you do lazy loading upfront. A collection of data will always has to be lazy loaded. You should be able to incrementally load data. Offline storage, caching on edge, yes. But if you're not connected to internet, the caching is not going to work. You need to also have local data storage as well on your mobile phone. It's not so much of enterprise architect's decision to have a local storage because that's a mobile app developer or engineer's headache. But then again, that should be part of the thing. The syncing might be a logic. There has to be API endpoints to sync data ever so frequently. You should expect that should happen. So now the third one, API backward compatibility. So our team was building a mobile app feature within an existing retail mobile banking app. It was one of the 5 banking large banking apps out there here in US states, and we were working for one of them, and we were building a feature within that app, right? So they have been, of course, all banks have mobile apps. Of course, they had a good user base of all the users using the app already. But what they wanted to do was they wanted to build a premier experience for their affluent customers. A premier experience for an affluent customers, it was a straightforward job. I mean, all you had to do is show a nice looking welcome screen if he or she is an affluent customer, and then move on, right? Do some promotions and move on, right? It was a simple thing. We built it, we tested it, we almost went to staging. And of course, one more thing I forgot is it wasn't something which can be done just on mobile phone, because that information has to come from backend. So there were changes required in backend and front end both, right? Front end being mobile phone, mobile apps, and the backend being where the APIs are. At the very end of the almost deployment, almost at the staging end, the question came up: did we test those APIs which were changed with the previous version of the app? And yes, of course, they were not tested, and we had to go back and do a lot of rework to fix that. But again, the point is, in a deployment lifecycle of mobile app, almost certainly only like less than 10% users on the latest version of the app, right? A lot of folks have turned off their auto updates. Even if you deploy every app store and Google console, they have a deployment strategy where they can let users use, the auto update also happens incrementally, like 100, 200, 1,000, and million or whatever, right? It doesn't happen right away. So expecting, like with web app, you deploy and you're there, right? Mobile phone, that is not true. You have to still support all your previous version. And we had a policy of supporting 6 versions. That's a policy where one of the companies did, but you could be having 12 versions back, right? Depends on how frequently you do updates. So you have to make sure your API is backward compatible. Now these are the blind spots. Okay, one more, sorry. So there's one more. One final thing is, of course, no one remembers password on the mobile, right? And that's a aspect of security where people will be using biometric. You don't want to be logged off your mobile phone, right? You want to be able to always be in session. It is frustrating if you have to enter your password again and again. Yes, biometric makes it simple, but again, having a token refresh and session management strategy is important, and that is something which enterprise architect has to be aware when they're doing it. And finally is device health attestation. What is that? I mean, you do not want to serve a response back to a device which is jailbroken or hacked. right? So there's certain posture check for devices that gets transmitted, and then you need APIs and endpoints to handle that. So think of all these blind spots as an enterprise architect. Now I know what I need to prioritize instead of thinking, oh, let me just get the data and be the functional side of it, right? Here we're talking about more operational and performance side of things as well. So what should our system look like, right? I mean, the ideas here are these are just some suggestions and ideas because I have had experience working with many of these things. But the main thing to begin with is important is that no, you cannot use your existing RESTful API right away. Yes, if it is a simple app and you don't really care for users' performance experience and you just want to do a PSU, go ahead and use RESTful. But if you really want to do right word, either use BFF. I hope many of you have heard of BFF is. There's backend for front end. Basically, that's just a um, that's just a gateway to real API, but then it makes sure that you can do those things which I said. Bulk the request together, reduce the payload. Your BFF can do that. If you want to get really smart, use GraphQL. That lets you do it in better style without having to do BFF or still do REST, right? You have to cache at edge and local. SQLite is the one of the databases which you use, which all the mobile devices support, which can cache or store data locally and sync with the server. Redis is your in-memory caching database, which you can deploy to clouds. Enterprise service bus for API management. This is where your backward compatibility. I mean, you could always build something out and make sure you're compatible and you're backward compatible, but you could also use this enterprise service bus for API management to do that job for you. MuleSoft and Dell Boomi is one of the examples, right? And finally, you can do OAuth 2.0, but make sure you use proof key for code exchange as a PKCE to do that, right? And finally, make sure that whatever you do, wherever you're storing data, you are encrypting it, right? That's encryption for any data at rest. Okay, again, another disclaimer, I am not an enterprise architect. So whatever you're gonna see the next slide, again, I forgot those balls. Efficiency, speed, and security, right? That's what we talked about. Now, again, the disclaimer again that I am not an enterprise architect. So whatever you're gonna see as a back of, what I'm gonna show you is a back of napkin, rough cut enterprise architect diagram for a mobile app. I'm sure there are folks here who are far better at doing this job for me, but just a thought process, right? Idea is straightforward. We think about these things of having load balancer, in-memory caching database, back end for front end, and OAuth right there, and start and designing for that. And then, of course, you have firewalls to talk to your your enterprise systems, right? So it's not that you cannot do enterprise systems. You cannot build enterprise system, adapt your enterprise systems to mobile, but you need that layer in the middle to make it happen. And that's where you have to think as an enterprise architect when you're building for mobile first world. Thank you, everyone.
All right, our next speaker is Dasan.
So, hello, friends. My name is Nishith, and I'm an architect. I'm a developer as well. I like calling myself as developer because I'm not just architecting. I'm also developing on grounds with a team and understanding what is it all about and like experiencing the scenarios. So what I learned over my 14 years of career or last few years of architecting is that architecture is more about a mindset, how we see the application. Like when I design something, like when we are at the beginning, like we see from the bottom to top approach, but as we move on, we see from top to bottom, right? And we see lots of things. So, of course, today my presentation is on like secure software architect for zero trust systems, right? And security is one of the biggest problem in any of the domains, like especially in BFSI domains a lot. And like there are lots of traditional approaches. I won't say traditional exactly because they are still being used. And now we are moving towards more advanced security mechanisms to prevent those shortcomings or the disadvantages of those previous approaches. Now, thing is that let me take so I always believe in whenever I see any problem, I always try to connect with a real life scenario. So let's take a real life scenario and then I can go on. Like, of course, these are things you can always get on Google, but I'd like to share my real life experiences and my working experiences with you guys as well as I go along with the slides, right? So let's take an example like you are at your home and someone steps in, right? That is like you check that, okay, that person is XYZ, your maybe your friend called John, and then, sorry, if John, don't mind if there's someone, right? And this steps in and then, so that is the first level of security that you have. You check, okay, this person is John or not, is your friend or not. So that is a kind of first level of authentication you get in. But the point is, once that guy, Mr. John or XYZ steps in, are you bothered once he gets inside your house? Definite, you cannot just go around with that person. What is John is doing? Let me track him. He might be using my washroom. He might be using my my clothes, and or he might be getting into my drawing room. He might be checking my kitchen. We don't bother these things like in a real life scenario. But what if that person is not your friend? Maybe the person is a lawyer or someone, your maintenance person, just example, right? And he gets in. You always want that if, for example, if the person is your air conditioner or a person who has to fix your kitchen tiles, for example, you always direct that person from door, that is the first check, and make sure that only he gets into the kitchen. And like a person, you cannot, sometimes you don't just exactly blindly trust on that person. You always keep a high level eye or eagle eye on that person. That person is only working in kitchen. Suppose that the person steps out and get into your study room. What will you say? Is it an alarming situation for everyone? You will think that, okay, oh, what happened? Why he has to work on the person has to work on the kitchen. Suddenly he gets into your maybe the safe areas or something that you don't want the person to be. And that's an alarming situation. Thing is that when we are designing architectures, especially when it comes to security, we only care, mostly in a general scenarios, we only care about the first level check. Like that is, a person is authenticated, that's sufficient. And once the person gets in, or once the service request gets in, we can always, that has access to everything. But the thing is that when we talk about the distributed architectures, it is always, we have to follow gradually, like most of the systems we are designing now from the past, at least we've been more than couple of years at least, it's a zero trust. I cannot trust a person or a request once it is authenticated at my first level at my API gateway. I must not believe that request for further actions as well. I should direct that only, that is the minimum privileges to do that work, right? I should only grant that minimum privilege to that particular request. I need to authenticate or authorize that person to only access the kitchen area, not any other area, because that person can do anything, right? Moving on to this, secure software architecture for zero trust systems. This is a traditional model. As I said, I won't say traditional because we are still, many of the systems are designed using this architecture. That is castle and a moat. So of course, as you know, traditional organization uses castle and a moat model, keep the threats out by securing the network parameters, firewalls, VPNs. Once inside systems and user were considered trusted, right? So when it comes to about VPNs and all, everything, once you get inside the system, you think, okay, the person is already trusted. It's, you already passed the authentication check. That's okay. I mean, like, but this system does have lots of failures. I just listed a couple of them. Cloud computing has dissolved the parameters, apps and data are now accessed from anywhere. Thing is, in a distributed, if you're talking about the monolithic, yes, it is fine to some extent only. But when it comes to a distributed architecture, there are now, of course, the mobile, any of the person, or it's a computer, web, there are multiple systems that is using your systems in a distributed environments. So in that case, it is very important to maintain the authenticity, authorizations of everything, every request coming from, particularly from where it is coming from, which particular device, how much access it needs to be granted. All these things needs to be tracked in terms of entitlements, very, very extensive designs when you're talking about, right? Then we talk about the bring your own device policies, whether remote work exposes network to unpredictable conditions. There could be n number of connections. We talk about concurrent connections and all. If anyone knows about ethical hacking, I'm also an ethical hacker as well. But actually we have been trained to try different connections, trying to attack from different regions, different combinations, whether it's SQL, and these are very small things, but of course, when it comes to the brute force or maybe a different type of or combinations we need to try in order to break the systems, trying to find out loopholes in it. These things we need to do when it comes to the hacking stuffs. The thing is that we are, as I said, from the past some time, we have started designing the zero trust, never trust, always verify. This is a simple principle that we are following these days in all the architectures that we are creating, right? Now, zero trust eliminates the assumption of trust based on network locations, right? So we're gonna, as I already been discussing that, okay, verify explicitly, least privilege access, assume breach, always keep on monitoring that, okay, like for example, I was talking about the maintenance person getting into your room, house. Keep on monitoring, okay, what he can do. I know sometimes, like in a real life scenario, it looks like a person is mad, like watching a person going around your house. But when it comes to distributed architecture, it is important that you can monitor every step of the request, that is where it is going through. Even when it, like, for example, but as I said, what are the benefits of it? Maybe it reduces the attacks, contains breach, provides visibilities and controls wherever the request is flowing. Maybe the flowing from method to method. Even there are 10 methods in your application. Even the request is flowing from one method to another, that request needs to be verified at every method level, or at least at a controller level and the applications, that, okay, whether it's really allowed to get in or not. Because every controller, once a user gets into it, especially if it is a repositories or entities, as soon as any request gets access to it, they can actually do that. They can actually manipulate the data, like provided you haven't added the separate read and write, or you're not implementing the CQRS architectures. Of course, that is an entire separate discussion, right? Moving forward, core principles of zero trust architectures, right? Simple, like never trust, always assume breach, enforce least privileges, authorizations, identify new parameters. Simple. So these are the basic principles, and I'm sure, like, we always imagine, but usually, like, I've seen like lots of applications that is not implementing these kind of architectures. Yeah. Let's talk about different places where where zero trust policies needs to be applied. Let's go talk about the DevSecOps for zero trust. When we talk, like, I will just take some of the examples, like for example, any code that is getting in, we always scan it with Sonar Cube and all, checking, vulnerabilities in the scans before it actually goes into the production environment. So these are the pre-preparations. When it comes to the static application security testing, dynamic application security testings in a build stage, we do that. Like usually, like in our applications, and especially in enterprise level applications, we always make sure that we create a pipeline.yml files, if you might be using these things, where we define that, okay, what are different scans you need to do, whether it's a pre-stage scan, you can actually define the rules in that YML file when you're creating those in maybe it's a Java or a Node or a .NET applications, you define those rules over there. And what is the expected output? How much percentage needs to be matched how much percentage of the vulnerabilities needs to be matched, or it needs to, we all set up the criteria as well. So these things, we do that. Signed artifacts, actually, whatever the artifacts we're using inside these days, any big companies or any enterprise level companies that is actually creating those enterprise level projects, we usually prefer that the artifacts, whatever it's getting inside the application, we are building the application, it goes through the proper scan, or it is, even if it is onboarded into the company, it has a proper signed certificate and all. That is also required in order to prevent the vulnerabilities. Also, policies as code, infrastructure, and deployment. So actually, we go through multiple scans every month or so in order to identify that the libraries are up to date. Like, just as I said, we don't trust that, okay, whatever is being built is actually going to work. Because even everyone might have went to Maven or Gradle, right? Maven side, you see that their numbers keep on sometimes rising, 200, 100 actually. These are vulnerabilities came out, then we are asked to update those things. So yeah, that's a continuous process that we actually should be watching even when we are developing any applications. This is actually the first part that I showed is DevOps part, where it is more of a preparation of the application. This is when we are developing an application. That is the second part of it. When we talk about, like, so I've taken some code examples as well, like, of course, principle like mutual TLS, ensuring both clients and server authenticate each other. Spire is actually, they create their own URIs actually, and then apply those rules on top of it. Sphere is actually the extension implementation of it. Role-based, attribute-based. So like, I think like if everyone is since everyone is working on securities, at least there are three things that we always consider when it comes to, like, first is the route authentication, authorization on the routes, or it could be on the method level, controller level, or further, it could be on the data level, attributes level. So these three level checks, we try to make sure that based on the roles as well, and based on a user. So the more extensive you create those entitlements at a user role level, the more at a device level, the type of device, maybe I want only the Android should access these kind of files. Maybe I want iOS to access these kind of files. Maybe at a region level as well, maybe at a policies, compliances level, GDPRs, there are lots of considerations. Accordingly, we need to define those rules, roles, user access in order to make sure that the right user with the right authorization and authentication should get only the access to the data that it is required to use only. That otherwise, that is the least privileges, right? Then, of course, we use all the JWTs, SPF tokens passed in, like, one of the examples I've taken is a pre-authorized, where based on role, it is actually adding an attribute level authentications. So that is more on an application side. Passport authentication design pattern is one of the design patterns that is actually used by some of the giants as well, where we talk about. So basically, thing is that sometimes, like, there's another thought is that, or that if you keep on authenticating a user, of course, there's a difference between authentication and authorizations, right? You can authenticate a user, but further, once you get the identity, you can keep on authorizing the users at different levels. So here, basically, passport authentication design patterns we are talking about enable secure identity propagations across microservices without repeated authentications. Repeated authentications, not authorization. Authorizations can be repeated n number of times, and it should be done. But when it comes to authentication, that's fine. Once a user is authenticated and passed through an API gateway, right? So your passport is created. But the point is, whether you have you should have, but then the second level check is visa to go where, in which particular part, right? So if you have a visa of one country, you cannot go to another place, right? Even you have a passport, right? So that's why sometimes you have also the expiry limits as well. Like when you get into any country, they also stamp that, okay, your start date is this, your entry date is this, your exit date is this as well, or max exit date. That is a max expiry time. As I mentioned, like when we talk about those scenarios, always try to connect with the real life scenarios. So I always try to do that. So it makes it more understandable that, okay, what I'm actually implementing rather than just blindly implementing what is there available, right? So that is something like, as I said, edge gateways. Edge is the edge part of a API gateway, authenticating external clients and issues, signed identity tokens. That is a passport. Passport token, signed JWT, HMAC. JWT, everyone knows. HMAC is actually the combination where we actually, there's some paddings, right, left padding. We use a secret key, and then we create that hash using SHA-256, depending upon how actually you wanted to make it more secure. Then we have internal services, trust and verify the passport. So once you have a passport, this internal service acts as a visa actually to get access the particular thing, like just connecting with the real life scenarios, right? Like our role-based or attribute-based policies. And then finally, the signature verifier, shared secret or public keys. That depends upon what kind of methodologies you are using in cryptographies, right? So that is more of like a passport authentication design patterns, like, right? The another thing is that it's more related to LLMs, right? In these days, it's very hard, like trusting an LLM, right? It's another task actually, because lots of companies like I'm not sure. I think everyone is using LLM here. I'm sure, but do you realize that we are only so you guys are? I think we are only scared about the data that is getting inside the LLM, but the second part of it, we should also be scared about protecting our LLM as well. It's not just protecting our data, protecting our LLM, right? How? The thing is, suppose we have of course, there are lots of PII informations. Of course, there's not yet 100% framework. We are talking about, there are lots of adaptive PII frameworks that is actually getting used in order to create the framework to prevent you use spacey. So if you talk about the first part, that is identifying the PII information, that should not go to the LLM. Even if your company has signed a contract with Google or any chat GPT, that they should not retain the data, but still, or as a company, we should always protect our PII information when it is going outside the network. So of course, there are lots of process. There are a couple of them is like using spacey, that is our open source models. Regex you can use in order to identify embeddings. You can create your own models in order to using the regex in order to create your own model, LLM model, in order to find identify these kind of PI informations. It cannot be 100% always, because till the textual part, it is fine. Structured data sets, you are good because you know the attributes name. But when it comes to unstructured data, when it comes, you're uploading the PDFs or XLS or any handwritten document, if I've written handwritten document as 1, 2, 3, multiple hash, and then it look like from the naked eyes, I can see it is an SSN number. But how this was how we need to identify through the regular expression that it's actually an SSN number. So you need to keep on training your model or upgrading your model in order to identify different scenarios, rather than just, of course, you cannot like blindly trust on those that is available. We keep on upgrading. Even the Spacey gives you an option to upgrade Spacey, or it's a name identity recognition models, like as I said, Spacey, custom transformers are there, right? But that is the first part of it. But the second thing is that once everyone is using prompt engineering, right? Suppose I say that, okay, deduct $100,000 from my account, or deduct $100,000 from the John's account. LLM should able to, or if we can say that destroy yourself, right? So we need to also, the second part is protecting your LLM to protect itself and also not prevent it from taking an action that can actually spoil or actually destroy your whole application. So even if it is going, I'm giving any particular command to the LLM, as a user, as a customer, or as a consumer, I can do anything. I can type anything, especially when it comes to the conversational models. When it is going to the consumer, right? They can type anything, right? But it's our responsibility to identify that what the user is typing, we need to identify what action it is going to take. Mapping the statement, converting the statement into the functions through the LLM, and then mapping it with the actions, and then ensuring that whether that user has a sufficient right to enable that action or not, and then checking that whether that action will, how much, what is the backup plan, what is the risk mitigations. These things we also need to identify when we are actually sending any particular prompt or to the LLM, because sometimes we want, in terms of agentic AIs, we want agents to take actions, right? It's not just fetching the information. We want that agent should take an action as well. But action could have the adverse effect as well. It could be negative. It is not always positive. We always think about the happy path, but actually the in real life scenario, happy path is just one path, but there are 99 scenarios that is an unhappy path actually that can make you cry and that will destroy your complete application. So even if you're sending any prompt, you need to make sure that it should be properly scanned, sanitized, and also mapped with the function. Even if the function is mapped, then also check whether the user who is actually asking for that is actually authorized, authenticated for that particular data, or take a particular action or not. That is our responsibility as well. Also, destroy word, these kind of words that can actually cause the trouble, like the thing is that your LLM could be connected to your vector database, for example, Chrome DB or a PG vector. I mean, sorry, Postgres as well, on which their PG vector is an extension, right? It could be connected to these things as well. So your LLM sometimes your LLM also has a complete access to your vector data to make your conversational APIs more effective. Sorry, it's not a AI talk, so but I just thought to refer that actually. Um, I was sorry. I might be diverting from the topic, so I've got into the AI stuff because we are working on the conversational APIs. AI is actually a lot. So as I said, like just to make sure that, of course, coming back to my slide, that of course, like LLM powered classifiers, fine tune your small models or detect the prompt injection attempts, right? Forget previous instructions. These kind of things you need to like parse and make sure that it should not get into your LLM. Or even if it gets into it, it shouldn't be. It should check that actually whether the person is really want that or not. Like anything that can hamper your LLM should also be protected, not just your data, right? So this is just a small diagram, LLM and the new surface attacks, actually user inputs, data leakage, right? Log and monitor it, sensitive interactions, model misuse, LLM, like generating malicious code as well. So you need to protect these things and protect your LLM along with the data, right? Right. So this just the last thing, like zero trust is a continuous journey, not the product. Secure identity propagations and LLM safety and core to modern design. So as I said, like security is more like how you see the systems and make it more secure in this in this crazy world of distributed architectures. It's highly required. Right? So that's how I conclude this session. Thank you so much for your time. I'm more than happy to entertain any questions, any scenarios, if I can help with.
All right, let's get another round of applause for all our speakers today. Thank you very much.